welcome to the webinar. As we said, it's the first one in this series, which is going to be great, and I'm quite enthusiastic to be able to talk to you guys about some of the things that we do, some things that we can help you with, and also maybe talk through some of the kind of technologies and ideas and some of the new things that maybe are coming along that you guys might be interested in. So that's really good. In terms of these webinars, and what they contain and what we talk about, that always comes from you people. Really, that's where we get the most from it, because it is really for you. So if anyone's got any ideas or thoughts and say, yeah, we've got these problems, it's really good if you could do a webinar, talk about that, then yeah, let us know. You can always let us know in this, or you can always get in touch with Dylan, which is great. Fantastic. So let's kick off. Let's have a think about some of the challenges in terms of obsolescence and aging equipment and aging systems. So I guess one of the biggest things is that usually systems are designed with longevity in mind, from a design and implementation standpoint, but there is often a number of factors that really kind of affect that. Often it's the implementation that's phased in. It's often asked for a 25-year lifespan, and actually with some of the systems now they've got that, but they're also asking for us to consider the fact that we've got a 2-year commissioning phase, building new systems, and also a 2-year decommissioning phase, giving us potentially a 29-year lifespan for these systems. So yeah, as we said, some things can move on in terms of technologies. Technology can be made redundant. They can just not be used anymore, and therefore being able to keep them running or be able to come up with simple replacements can be quite difficult. PSTN and ISDN are fair examples of that, that are used for phone systems and internet connections. ISDN was supposed to be removed, and circuits no longer sold in 2020, but that was postponed, and it's now September 2023 at the current state, with both ISDN and PSDN going and no longer available and actually been removed from systems by about 2025 by BT. So people have got to start thinking about other ways of making their secure broadband and internet connections, as well as their phone systems as well. A lot of phone systems still use ISDN, and we're going to talk in more detail about some of that as we come up. Again, the use of analog CCTV, anyone who's got a TNS, a telephony and security network as part of their systems, will be aware of those, and the fact that originally they may have been analog CCTV, and those cameras, especially if they're on shorelines and they're on offshore and that type of thing, start to deteriorate and stop working. Finding replacements for those is becoming increasingly difficult as well. One of the other challenges that hardware manufacturers just simply don't provide warranties for those life cycles being requested. I don't think there's really anyone who provides a 25-year warranty on a piece of hardware. Often 5 years maximum, with a few that have maybe what they call a limited lifetime on certain components, and even then it's their discretion as whether they've got the equipment and the ability to repair that or offer you a repaired replacement, because it's obviously not used, often new. Also, communications connections that have been installed over time can start to deteriorate. Cabling installations, fiber installations, with the potential cost of millions to replace, and also, could mean the entire shutdown of entire generation if those connections fail. The other challenge that we've noticed, obviously, as a company who bids for these types of works, is that these large-scale projects often are won by tender, and often there's lots of support in that early life without always that consideration for the long term. And also in a lot of cases, assets get sold after their initial early life period, so they will run for 5 years under the company that won the tender and actually it puts that equipment in and systems in, whether that's a wind farm, whether that's a gas gen site, whatever that is, and then after that period it can potentially get sold off, either because the owner no longer wants to do that and they want to just get paid for their investment, or simply it's a requirement from the UK government for things like wind farms and things. So yeah, what can happen is the early life's great, and as that moves into that period, the long-term support can start to fail. Maybe documentation's not in the correct places and where it needs to be. It may have been fantastic and sufficient when it was first done, but being able to keep hold of that throughout the life cycle, it can be extremely difficult as well. And therefore, understanding how you are going to take a system that's getting older and being able to either do upgrades to that system, replace damaged equipment, and things like that can also be quite difficult as well. So let's have a look at the solution to obsolescence. In terms of networks, one of the first things is ensure there are spares. If equipment's not going to be made anymore, it's good to make sure we've got some spares. Quite often in this type of arena and world, certain devices such as network switches, they're often modular, and therefore you can have different parts. So you may have different power supplies or different modules that fit in the device. That's always quite key to certainly in the midterm, the first 5, 8, 10 years, etc. Ensure you've got backups of all equipment. Now, if we've got configurations that if a device fails, we've got the ability to be able to either bring the same device online. Also, in that respect, with configurations, it's all making sure you've got firmware as well. You may get hold of a device or being able to buy or purchase a new piece of equipment, but it may automatically come with newer firmware. And therefore, your ability to put that configuration onto that piece of equipment could also be a problem. So having firmware as well as configuration is also extremely important. Even if that configuration is human readable, that's also useful, because we may be able to interpret that and go, oh, okay, this is what was trying to happen with that equipment. If we need to have a new piece of equipment that can't take the configuration directly, we've still got the ability to read it, build a new configuration for a new piece of equipment, or even on newer firmware. So yeah, super important. Make sure your systems are fully documented down to each physical connection. We know from some of the newer systems that we do that, but I know from some of the older systems we come and we ask for documentation at the point where we're surveying or we're investigating any updates, upgrades, or repairs to systems that we've been involved in. And sometimes it's either not available or it's very difficult to get hold of. So yeah, making sure they're documented. So if you've got an older system, it's probably worth having a look at that. Have we got all the documentation? If not, maybe it's a good time to start creating it. So we've got the ability to look after that system in the long term, and start to investigate some alternatives for equipment as well. Whether that's network switching, whether that's phone systems, whether that's SCADA equipment and things like that. It's certainly worth investigating alternatives rather than thinking you're safe in the knowledge that you're able to carry on going to the manufacturer for the same equipment that maybe is a decade old and they may have superseded. Couple of little things just on that. IT hardware like switches, fiber modules, that fit into switches and things like that, they're largely unchanged for many years, which means moving to a different model or a manufacturer is actually relatively feasible. The only thing I do say for that is do check for compatibility. Systems when they were first put in, maybe using older devices, maybe the fiber optic modules that we used were 100 meg modules, for example, and some manufacturers of switches, even today, they may only take either a 100 meg module or a newer gigabit module, for example, for more bandwidth, and they may only do one or the other. So if you're buying a new device and you get it with gigabit compatibility, it may not be 100 meg compatibility and therefore won't work with a switch that's maybe connected 10, 20, 30 kilometers away. So it's worth checking that compatibility just to make sure that it's either going to be compatible with your existing equipment or has the ability to maybe do 100 meg and maybe upgrade to a gigabit later, which you can do sometimes. If possible, I know this is a difficult one, create some small labs with that spare equipment, check it's working. Is it actually physically working? And also that would allow us to then test compatibility with old and new equipment and make sure it does work prior to us trying to replace old equipment with new. Even from manufacturers, they may be able to give new features and also be cheaper than older models. So as it happens in your sector, most hardware is already built to a very high mean time to failure. So, and it's often how these 25-year lifespans are sold. We're not going to warranty it for 5, 8 years, 10 years, or plus 25 years, but our mean time to failure, so from these things running for a very long time and some tests that have been done, then we've worked out that theoretically the average that a switch would fail is once every whenever that is, 15 years, 20 years, wherever it is. And they also have a very stable release roadmap. It's not like some of the more maybe enterprise or next generation devices where hardware models may change a lot, firmware and features may change a lot. These tend to be much more stable, so their hardware will be sold for longer. The firmware and the releases thereof are usually a lot more stable as well. So that does mean that you've got a longer lifespan generally than some of the more consumer/enterprise products. However, doing that means that maybe certain components, capacitors, other sorts of things, but certainly other components, chips and all the other things, they are not being bought in the same quantities and therefore would cost more, and therefore sometimes actually some of the older kit to try and still buy a model of an old device can be more expensive than buying newer kit as well. So yeah, the other thing is that upgrades for switches such as telephony and security networks can of course include things like PoE+, and we can certainly get that in rugged devices these days. So where you have had to power things like cameras and phones separately, they can now be powered from those switches as well, and therefore cut down on the amount of power devices, allow them to be rebooted remotely and other such features such as that. So yeah, it's always worth investigating whether going to a newer device would give you more benefit when you were replacing and updating systems. The other thing to note is that certain network equipment in this arena would often be from specialist manufacturers such as Rugged-Com, Hirschman, all those types of things that a lot of people have probably heard from, which is great. But what I certainly find in the security arena, and maybe we've got a few people on who kind of working specifically in that area, is that a lot of the routers and things like that that you may be using for connecting some of your different systems together, or so that they can be connected via a DMZ, so they can be looked at and monitored from a remote location. They're often based on quite basic Unix, Linux-based routers with very basic software firewalls, and also rudimentary resilience, such as VRRP as a redundancy protocol for having, say, two routers in the same rack for resilience. Enterprise and data center manufacturers like Cisco and Fortinet, who in terms of an enterprise, have been delivering these enterprise products and delivering new features, some of the latest security, and also things such as SD-WAN, which I will talk about a little bit later on, because we are doing that for a few people now to create redundant connections with redundant firewalls, which are resilient to your systems and your kit that you're using, but will give secure access and give more secure access than something like that. So these now can be bought with the BSEN 61850, which means they're allowed to be used in substations and certified for substation, which is great for somebody as a security person like myself. That's fantastic, and hopefully opening up a new world of connectivity and security CNI, which is superb. So yeah, how do we go about this replacement and improving? Traditionally, different systems could use different networks, and that kind of hangover kind of moved on when things went into a network world. The different systems carried on using different sets of connectivity. I know I've been to sites even today, whereby the system you'd need to design separate telephone and internet ports, which was great back in the day when BT would install your telephone cable, maybe with Cat3 or older, and then an IT or a network company would install Cat5 or Cat6 or whatever, and they would be separate. It's all the same stuff now. It's all Cat5, in a in a corporate world or an enterprise world, we put in structured cabling in, which is the same cabling in every space, and it's used for different things, whether that be for connecting computers and systems. Maybe it's connecting your telephones, maybe it's connecting projectors and all that type of stuff. So what we can do with that is actually say, well, actually, this is just cable. So we don't have to think of it as separate cabling anymore, even though that kind of hangover still exists sometimes. And we can also consolidate some of our networking as well. So instead of, in this example here, we may have separate switching and connectivity for our telephony and security. We can have separate systems for, or certainly separate networks for SCADA and even things like DTS and things like that. We're aware that things such as intertripping and the actual DTS components in terms of the temperature sensing require certain cores, and we're aware of that. But the actual network connecting to those DTS monitoring devices can often be separate as well. We do also appreciate the fact that sometimes it's not as simple as just connecting into one big network. We understand that sometimes different types of assets do get sold off separately, and we know in the UK that's sometimes a requirement. So yes, we can't always put it on the same switching hardware just because of the way that the ownership works, but there's certainly a lot of scope for us to reduce the amount of IT overhead that a system has. So switching can be consolidated, so we don't have those multiple stacks of switches, and we can use that to create these multiple network services using virtual LANs instead of actual LANs full of separate networks with separate switches, or VLANs. We are, as I said, we are aware of separate network requirements where multiple asset owners, such as OFTOs and WFOs and those sorts of things, depending on your area of the business, may be sold off separately. And we can see already we're using far less fiber cores. If we've got 120 meters of fiber connectivity going on, it's a very expensive resource. So if we've got the ability to make use of less of that, we've got other cores that we can use for other services. We've got other cores we can use for backup, etc., etc. So we can automatically start using less of those. Also, when it comes to connectivity to firewalls and things, it's all a little bit simpler as well. We can trunk that into routers and things like that. And in some respects, we can create more overall resilience rather than less, because we can put in potentially more switches to create more resilience if we want to. So instead of having 2 OFTO switches, we could put 3, we could put 4, if resilience was required, while still using a small number of cores that connect the kind of core together, if you like. So when it comes to planning for change, I guess a lot of people say, well, how can a 24/7 system be upgraded? How can we take that? How can we do that without either taking it offline at all or just by minimizing that as much as possible? Key one is planning, of course. We could create designs, plans, change documents, testing. Does the existing system have resilience? We're going to talk about, and I'm going to show you some examples shortly, whereby there's we can work alongside your systems potentially, or at least maybe take half offline, leaving it running while we use the part of the system to put in the new equipment. Could those updates be delivered in stages so that we deliver some first key benefits and then start to make other improvements now we've got that kind of core system in place? And as I said, could it operate alongside the existing system? So how do we support our clients? I think the main thing here, and as part of this webinar, as I said, it's kind of a bit of a overview of a kind of the certain types of things that you could start to look at and do. But there certainly is no one size fits all. CNI is a very big area of the world with lots of things. So we work with lots of different clients in different areas, such as gas treatment and distribution, power stations, wind farms, both old and new, absolutely brand new. We did a lot of communication work for Triton Knoll Wind Farm in the last year, so that was a couple of years worth of effort and work on our behalf. Battery storage and distribution sites, solar energy, and also in nuclear as well. So work in a lot of different areas, and it's just about listening to the problems and look at how we can solve that problem, either with older, problems that people are having with older equipment or with failing infrastructure. And things like that. And the idea is that what we've really noted with all these different areas is that there's lots of areas of technology that you guys share, but there's also lots of things that you do in the way you do it that's also quite unique to the kind of the specific area that you guys work in as well. So that's always really good for us, because we're able to say, well, actually these guys are doing this and it's a really good benefit, and I think we could help you guys do something similar. So it's been really good for us to be able to do that and ensure that these systems can continue to work year after year. So let's have a look at some of the kind of technologies and the kind of solutions that we look at. One of those first ones is an IT technology called SD-WAN, or software defined WAN. So the intention here is we can essentially connect 3 different internet connections, for lack of a word, or site connections, let's call it that. And in this example, we've got a BT lease line that doesn't go out to the internet, so that's a directly connected fiber optic from one place to another. But we do have a couple of internet connections as well, and within that we can create 3 secure connections, and we can prioritize one over another, and the system monitors that. So it's got the ability to monitor it, pick the best one, but not only a case of if that goes down, it goes off, use the next one, but look at the quality of that connection, really important. Because what we can do is, if that just becomes a little bit rubbish, it starts to fail a little bit, we're getting some loss of data, it can then jump to the next one, and it can wait for the other one to become better before it moves back to the primary connection again. So that's kind of my 30-second synopsis of SD-WAN. I've done some full webinars on that subject in the past, so it's quite a big subject, but that's my 30-second synopsis of what that can achieve for people. And then on top of that, we can start to not only do the main SCADA systems, but also doing things such as tannoy and intercom. We've done that for people as well, whereby it might be basically, I don't know if anyone's seen this in kind of supermarkets where they'll pick up a phone, dial an extension, and it comes out of the tannoy. We've got people who still have systems like that, and our ability to send that across an IP network as well as potentially involving CCTV and creating prioritization. So we always prioritize that SCADA traffic over all of the other traffic, because clearly if that goes off, then potentially systems start working as well. So in areas where maybe fiber, as we said, maybe fiber starting to become a problem, maybe there's going to be a breakdown, and maybe some of the cores are starting to fail, and therefore we haven't got as many available. Things like this are really good in terms of maybe creating a midterm solution while other solutions are thought about. So with something like muxing, we can take 2 cores of fiber and we can send different frequencies of light down that, essentially, because we're sending a laser light. That's what fiber optic is and what it does. So we can send different frequencies down it. So we can send all these different frequencies down, up to 8 in this case, and then we can send that, put it all together, send it down that fiber, and then we can split it back out the other end. So that allows us in this case to take what would have gone down 16 cores of cable and send it down 2, which is really useful indeed. So we've had a couple of instances of this where we've had phone systems. First thing is, as we said already, PSTN, ISDN trunks. If anyone's got 20 direct dials, for example, they're most likely done using ISDN. Thinking of new technologies and things like that to replace those is key. Obviously, if that thing on the left, we know numerous people have got those. Old Siemens PBXs. If they're resilient, you've got 2 of them, so they're taking up half to 3/4 of a rack. Depending on the solution, if they've still got maybe some analog connections and things like that, we may choose something like the one on the right at the top there, the green one. So that will allow us to create a lot of extensions. It will allow us to still connect ISDN in the interim and things like that. As you can see, much smaller package. It also, for those people who do have the stuff on the left, licensing can be extremely expensive for a lot of extension numbers in these types of things. We've also got a method of migrating your licensing off off the old Siemens stuff as well, which means that the license that you would then have on your newer system would be quite a bit cheaper. The other one, which is the tiny little one, that's more for if people got VoIP phones and we're going to be taking you off ISDN and moving you to, say, SIP connections and things like that, we can actually use something and replace that entire box with something that's that big, and we could put 2 of them in a 1U package. So we've suddenly gone from taking up a half to 2/3 of a rack to 1U, and the power involved and the connectivity involved as well. So yeah, obviously a lot of you guys have CCTV, and obviously when wind farms are first built, it's a lot easier to fit them on the equipment before it gets floated out to sea. So a lot of people are still using analog CCTV, and obviously being able to replace that cable with network cable offshore can be extremely difficult and challenging. And actually some of the older power stations that maybe use things like coax and other technologies as well, maybe that, you know, that's another one where it might be extremely difficult to replace that coax. This is just an example where maybe using the mixed stainless cameras. There are a couple of companies that intentionally have built their products like the ones on the right there. First, they look sufficiently similar. The second thing is they use the same cable and the same bolting mechanisms. So it's relatively simple to replace the one on the left with the one on the right. The thing about the one on the right is it's hybrid. So you can connect the coax cable to it and it will carry on working in that analog manner. What we can also do with that is if we can get a network cable to that power supply, so not all the way to the head of the camera, but just to its power supply, then we can turn that into an IP camera, and we can turn it into, and we can get things like such as HD and, you know, connection into more modern recording systems and things like that for people. So yeah, those are some benefits that we can also bring in with CCTV and things like that. There's certainly lots of other areas that we get involved in terms of security and things, and we're happy to talk about those maybe in another webinar. And as we said there, just that's kind of the thing that we do, where we keep the existing Bosch cable because it's all in your conduit and your stainless steel trunking and all the other stuff, and we simply replace the camera and the power supply, use the existing coax at first, and maybe upgrade that to network cable if available. So that's kind of a bit of a whirlwind tour, if you like, of how we may be able to help you guys, and maybe some things that you guys can look at in terms of your systems. And maybe if you've got some questions or anything specific to yourselves, as I say, you know, you all work in unique areas of CNI, and therefore some of the ideas and solutions and maybe the problems that you're having may be different. So we'd be quite keen to speak to you guys. You can always get in touch with Dylan, and you can always get in touch with myself. Maybe if you want to ask any questions on here, that's cool too. But yeah, if anyone's got any questions, then yeah, feel free to ask them.
Mick, we actually do have some questions. There's been a couple that popped in. A couple have popped up as you've been going. So one of the ones was, you mentioned listening to the problems within the CNI customers. What are some of the common themes within the industries? Like your top 3, for example, the common theme.
Common 3, probably probably aging switch, because obviously we're quite network based, switching, aging switching and SCADA architectures. And yeah, you'll have a switch blow up, and then suddenly, I mean, don't get me wrong, a lot of these places, again, you guys, they're built resiliently, so so often that's probably one of the top ones is equipment stopping working. How do we get a new version of that, or how do we try and get the same thing? Documentation, so looking to get documentation for either the network and SCADA systems or for the TNS systems years later seems to be a big problem, and that's difficult then, because we've got to try and dig into equipment, or maybe trying to break into it, as in try and get usernames and passwords for equipment can be quite difficult. So documentation is probably the second one. Probably cabling challenges is next, because again, I guess that could be linked to documentation, because again, we ask for, you know, you look in, okay, where are the ducts? So if I've got a post and it's got equipment on it, how's that cable back to your control and comms rooms, so that if we do need to replace cable, how do we duct that through without doing lots of civils? So yeah, those are probably the main 3.
And we also have another question. It says, when you replace equipment, do you do a test prior to implementing the plan?
Yeah, in terms of us as a business and the way we do things, obviously, yeah, we can do plans and we can configure equipment, and then we'll have generally a two-stage process. One of them is an FAT or a factory acceptance, and that's where if we are working with clients, we'll say, have you got any spares? Have you got any of this old equipment? Sometimes we can try and get that or obtain it, but sometimes that's very difficult. So we'll always do some kind of factory acceptance. And then we may have a single SAT or a site acceptance testing, or a staged one, depending on the system that we're upgrading or replacing. Yeah.
Okay, and there's no more questions, so.
No, that's fine. Good stuff. Excellent.
So in terms, thanks to everyone for joining us today in our first of hopefully many and wonderful webinars. We're going to have another one on the 20th of April. I'll send out a meeting invite and extra information on it, and we'll be joined by an expert from Milestone. So I'll send out all the additional information as well as the recording of this webinar to everybody. So thanks everyone for joining our first one.
Brilliant. Thank you very much.
All right. Goodbye, everyone.